The next stop after processing the photos is photogrammetry in reality capture, or the process of reconstructing the mesh out of these photos. In the top of the user interface, I will switch to 1+1 layout, and then we need to add the inputs. Once again, I will resort to drag and dropping into this tab. Still 44 images, meaning that we haven't lost anything in the process. You can check the resolution of the selected inputs, 2K pixels wide, like it should. It will also affect the price among other things. And now just hit the start button to create a virtual reality. Actually, no. It's never a good idea to do it like this. What we should do instead is tackle the workflow steps one by one, starting with aligning the images, then calculating the model, so on and so forth. So down into the settings of the alignment tab, let's check the image downscale factor. I think it is important to point out how the image downscale factor works in reality capture, because it can definitely be slightly non-intuitive. Basically, it's a multiple by which the application reduces the size of an image before feature detection. For example, if you input 3 in there, you tell RC to downscale the source images by the factor of 3. And if you input 1 in there, it's basically no downscale at all. I think the value of 2 is a nice starting point, so let's go with 2. And in the advanced settings, pretty much everything at their default values except the preselector features, which I cranked up a little bit. By default, reality capture keeps this value pretty modest. I don't remember exactly what it is, but in my tests, cranking it up to something like 40 or 50,000 resulted in more reliable camera matching. Okay, let's hit align images. It should be a quick process, considering that the initial resolution was pretty low. Luckily, all 44 cameras have been matched. You can see that point cloud, which is the sparse point cloud. Within the Tools menu, we have the reconstruction region, which can be cleared, and the ground plane that can be adjusted. After clicking the ground plane icon, you will see the gizmo, and by using this gizmo, you can orient the model in space. It's usually better to do it from the orthographic projections, like the top one. And while it's not strictly necessary, it usually makes the life a little bit easier on processing the mesh later on. Aligning it from the left perspective, then from the front view. It's not clear whether the ground is a little bit tilted or the object itself. Okay, now back into the perspective view. Looks to me like it's oriented very nicely, and now we can set the reconstruction region. It can be shrunk down and tailored to the object by adjusting the handles. And it tells reality capture to process the mesh only within the confinement of this bounding box. Obviously, it helps to save up the computer resources, especially if the sparse point cloud extends far beyond that bounding box. The next logical step after obtaining the sparse point cloud is to turn it into the dense point cloud and to mesh it. These two operations are joined in reality capture. So let's head over to the mesh model settings, image depth map calculations, and within the normal model tab, let's check the image downscale. As depth maps and mesh calculation is the most resource intensive step in the whole photogrammetry pipeline, you should be careful with the image downscale. 1, meaning the original resolution, is not usually the best option right out of the box, but I know what I'm doing, and we have resized the source photos anyway. Remember? So I went with the image downscale of 1, meaning the original resolution. And voila! After some 10 minutes of processing, which is blazing fast compared to many other software, reality capture really shines in that department, we got a pretty high quality mesh with 4.6 million triangles. I will call it high poly, because naming is really important. I will keep reminding ourselves about the importance of naming throughout the course. Okay, so right after meshing, we can proceed with colorizing the asset. I'm checking that the texturing and coloring resize is set to 1 in the colorize settings and pressing the big bad button. Unlike texturing, colorizing uses vertex colors. It neither generates an UV map or texture. It just assigns the colors to the individual vertices of the model. And if the density of the vertices is enough, I think 5 million triangles is close to being enough in that sense. The final result looks just like a texture. Not having the UV map and the texture can be an advantage if you have to sculpt the model or if you don't want to spend time generating textures. And in some cases, texturing the really high poly model is practically impossible anyway. Alright, so here we got a nice high poly base mesh with colors assigned to vertices. After that, to make the model actually usable, it usually has to be trimmed or cleaned up in some way. Even before taking this model to Blender for the mesh doctor work, it's possible to do some cleanup in reality capture. For example, with the help of the lasso selection tool and the filter command. First of all, I will clear the reconstruction region because it messes with the selection. And then I will isolate the part of the model that isn't the road block. You need a pretty steady hand in order to do that. With Control, you can add to the selection, and with Shift, subtract from it. So it's helpful to do it in a few steps, without trying to nail everything at once, in other words. So I'm proceeding slowly and carefully with selection. Once again, with holding the Control key, you can add to it. And by holding Shift, remove the parts of the selection. If you feel more comfortable with doing it in Blender with the help of the Boolean tools or just good old selection in edit mode, go for it. In my opinion, the RC selection is slightly faster for the time being, especially when the mesh is spectacularly high polygonal, which is not the case here. Once the selection is finalized, I'm pressing the Filter Selection button within the Tools menu. That will delete the selected polygons, basically. And it will create a duplicate of the model with these areas cleaned up as well. Let's call it high poly _ trimmed or something like that. So this will be our high poly model that we will be working on in Blender. So I'm gonna hit Export. We need to find the FBX format. Create a separate folder for the high poly model and just dump it into there after licensing the inputs, because the pay per input license means that we need to pay for the inputs first. As far as I remember, for this particular model it was something like $0.25, so pretty affordable indeed. But anyway, that's something to keep in mind, that reality capture is still a paid application. Okay, so the model should be exported now. Let's pick it up in Blender.